Okay, so hopefully you got opposite of b over 2 times a. Is this number a positive number or a negative number? Positive what? Positive 3. How did we get 28 again? Okay, now. So I got my 3. What am I going to do with it? Why we have people that are saying things like, I don't know how to find the vertex. What do we do with this? Plug it in. Okay, now you tell me what I'm doing wrong. Whoa, that was fast. She said I forgot the negative sign. Is that true? I forgot this negative sign right here. Okay, I suggest you use parentheses as I have always suggested to you. 3 squared is how much? 3 squared, that's 9, but you got a negative 1. So that is a negative 9. Then I've got a positive 18 and a negative 8. So you forgot that negative 2. Okay, so 18 take away 17, also known as 1. Okay, now, I know we could do the rest of that, but we're not going to. What I want to think through is question 2. Because several of you are saying things like this. I don't know where to start. Is the strategy of where I start on this graphing question any different than the strategy you used on the first question to find the axis of symmetry? No, it's not any different. After you find that axis of symmetry, what are you going to do with that to find the rest of the vertex? Plug it in, right? The strategy of what we did in question 1 is no different than how I start this question. But once I find that vertex, you know whether it opens up or down. I'm curious. Open up. It opens up. So from that point, we use the 1A, 3A method of graphing to find other points. That's the only difference, right? But the start of both questions is the same. Those are review questions. I want to know on question 3, because some of you didn't know what to do with that 104. What are we supposed to do with this profit of 104? Plug it in, right? And so some of you did that. 104 equals negative 0.5 x squared plus 25x minus. Some of us were doing that, others were not. Some of us were subtracting the 104 to the other side to give us 0 equals negative 0.5 x squared plus 25x minus 275. What was the purpose of doing that? So that we could do what? We needed in standard form set equal to 0 so that we can do what? Solve it using what method? Smiling about it means we're not paying attention. I'm not going to graph that thing. I could, but that would be kind of ugly. How about the quadratic formula? You know, that thing that's written on the chalkboard up there that starts out with a discriminant and then you find the rest of it? Okay, we're not going through that right now. I just wanted to know if you could remember the first part. I'm pretty sure you know how to use the quadratic formula. It's a matter of getting it ready for the quadratic formula that worries me. Okay. This is also a review question, but it's a review question from section 5.1 if you want to go back and look at your notes. But please put that in standard form right now. Put it in standard form, and then answer the bottom 2 questions on classifying it. what's standard form for this? What is standard form for question 4? 4x to the third. You saw that they were like terms, and so you added them together. Good idea. It's kind of hard to screw up standard form if there's only one term. Okay. What'd you call it? Cubic? Monomial, that's true. Third degree, one term. Okay, question 5 is also review. What part of this polynomial do I need to pay attention to determine the right and left end behavior? The leading term, right? We abbreviated it LT for leading term. So, we decided what would happen on the right end behavior first. Figure out what happens here first and here second. Go. Find the yes, is, that kind of stuff. So figure out what the right end behavior is first. Look at that leading term and decide about it. So the -6 tells me the right end behavior is down. What is the odd degree telling me about the left? It is opposite of the right, which means it's up. So we knew as soon as we got the down over here, I saw some of you crossing those two off. That's good, because that means I understand that you saw that the right end behavior was wrong. And you got rid of those two choices. Then you went to this one right here. Once you figured out that the odd degree meant that the left was opposite, which is exactly what Florida Georgia Line is singing about in this song. Okay, they're singing about polynomials with this type of end behavior. Just thought I would remind you. People in the real world sing about polynomial end behavior. Okay? Okay, I need you to tell me, these are called factors, right? Does everybody know that those are called factors? The question is asking me about the zeros. So, yes, I know that we could set each one of these equal to 0, which I've shown you many times before, and you probably don't even need to do this now that you've done it so many times. What are the zeros? -4, +5, and +6. A lot of you know that information. Okay? What is the leading term? If I were to FOIL this all out, which I don't need to do, by the way, I need the leading term. This would be x times x times x. What do we call that? X cubed. Okay, so what do I know about the right end behavior? The right end behavior, since I have a leading coefficient of positive 1, right? So the right end behavior is up. I've got an odd degree, so what does that tell me about the left? It is opposite. I need you to make a selection A, B, C, D based upon the correct end behavior and the correct zeros. Correct end behavior, correct zeros. Which two have the wrong end behavior? A and B. So I should see on your paper, when you're taking a test like this, I should see you cross off those two because they have the wrong end behavior. We're really choosing between B and C. Those are the only ones that have down on the left and up on the right. So I've got somebody over here voting for B. Is that true? You would be correct because negative 4, 5, and 6 are the three zeros of that. So, good answer. Question 7. So far we've been doing a lot of review. We're going to introduce a new concept today, which you will be going over on your flex day. Okay? Now, I'll record the video for the flex day notes after school today, maybe 6th period, depending on if I get time. And I will put it in Canvas, on the Canvas page for section 5.3, I believe. Maybe 5.4. I'll have to look at it and see which one. But there'll be a Canvas page that you can easily see. It'll all be spelled out on the Google sheet as well. Okay? But you should go watch the video and take the notes. You will be given half credit for doing the digital portion. When you come to class with those either printed or digital notes that you took, you get the other half. Okay? Just like we do on all flex days and e-learning days. Okay? It'll be 30 minutes. I'll make sure that we don't go over 30 minutes. That's all I want of your time. Okay? But if you don't do the assignment, you are counted absent, which it shouldn't be that hard to give me 30 minutes of your time since you give me 45 on a daily basis. Okay, so is there a GCF on this question? What is it? Negative 4x, thank you very much. I would take the negative. I know that the negative is not the most obvious thing in the whole wide world, but I like to turn this first term into a positive term. So by removing that negative with it, it makes my life easier. So if I'm dividing everything by negative 4x, what's left? X squared plus what? Plus 3x. Good, good. Minus 10, right? You got a positive over a negative. That's got to be a negative. Okay. Question, can you factor it further? Go. Can you factor it further? That's what I need you to do now. Factor that even more.
Okay, what did we boil it down to? X and X. X plus 5 and X minus 2. Does this give us the correct end product? Well, the only choices for 10 are going to be 10 and 1 or 5 and 2. Those are the only choices I have. And so then I have to think about it, okay, what's going to multiply together to give me negative 10, but add up to positive 3? This does work, right? 5x and negative 2x. That does add up to 3x. So we're good. We got it. Question. Is this all I have to do for question 7? I will cross this off, but let me ask you this. Is that all you have to do? Are we done with this question? Yep, folks, we factored it. We're good. So I know some other questions that'll ask you for zeros, but this didn't ask me for zeros. It just asked me to factor. So I'm not going to waste any more time on that one. We'll move on. Okay, what is that line from Frozen? What does she sing? She's singing to her sister on the other side of the door. Okay, that's what it reminded me of. You know, can you hear me? I thought, is that a line in that song?
Yeah, she says that. She's like, or something like that. Yeah, I think she says,
Okay.
People are asking where you've been. It is in there.
Okay, all right, cool. All right, we're going to jump down to question 13. Okay? Question 13. When we get more complicated polynomials, first of all, okay, I need everybody's attention. This is a new concept. Yes, even you. So I add the 20 to the other side, we get x cubed minus 2x squared minus 19x plus 20. Okay. And yes, that's equal to 0, but, you know. These questions have to have 1 0 for you to start with. So I will be adding to this question something like this. Hint. Negative 4 is a 0. If you don't have that, you're going to have a real difficult time starting this process. So I will have to alter the question and physically give you one of the solutions. So, look right here. It says the real solutions of the equation are. Now, I'll give you a hint. That's the number of solutions there are. There are 3 solutions to this question. All right. Now, we could have less than that, but we're going to try to be nice to you. And if it's a 3rd degree polynomial, we'll have 3 solutions. If it's a 4th degree polynomial, we'll have 4 solutions. What solution do you think better be on this line? Oh my goodness! Do you know how many kids never write down the one I give them? I'm like, are you kidding me? I give it to you and you don't even write it down. Okay? So, that should be the start of your problem, right there. Now, what I'm about to write down is a process called synthetic division. Let me write it out first before you start copying it, okay? Because at first it might not make, all the sense in the world, but I need you to understand we are not going to be doing long division. We are only going to focus on a process called synthetic division, okay? This is what you're going to be practicing more of tomorrow on your flex day, or tonight if you choose to do it before you go to bed tonight, which I know some of you will, and I understand why. Okay, doesn't bother me at all. I know. Well, what's funny is there are school districts which tell. I know for a fact one of them, because my kids go to it. Anyway, they're instructed not to give the e-learning or the flex day stuff until the next morning. I'm like, are you kidding me? If they want to do their homework, let them do it. I don't care when they do it. Okay? I'm like, seriously, what is wrong with this picture? But that's what they're told. And I mean, I know this because I have a friend who's a teacher over in that district, and he told me what they were instructed. So I'm like, okay, all right, whatever. Probably, but I'm working here. All right, so he'll just have to bleed out. Okay. Okay. Use a tourniquet. Save the arm. Okay, so let me write this down. I'm starting with -4. Okay, I'm going to put a little box around it. And then I'm going to write down the coefficients of the polynomial I'm starting with. The coefficients, and I'm underlining them in blue right now, are as follows. 1, -2, -19, and 20. Now, I didn't write down any of the x's with it. I don't need to. I am going to kind of put a vertical line here, and then I'm going to put a horizontal line through here. Now, notice that I left a whole row of space underneath those blue numbers. So, copy that down while I go get a band. There you go.
Thank you.
Okay, got that copied down? All right, I need you to follow this process. It's really a simple two-step process. Okay, first, now before, this is kind of the entry-level step, and then we're going to repeat 2 steps over and over and over till we get done. The first thing I do is I carry the first number down below the line. I draw an arrow so you understand that all I'm really doing is copying it down below. All right, then I'm going to start my process of synthetic division. What is -4 times 1? So I am multiplying here, folks. That is -4. Now watch where I put it. I'm going to put it in the next column above the blue line. And then I'm going to add down the column. So when I add -2 and -4, what do I get? -6. Okay? Now I'm going to repeat those same 2 steps. -4 times -6. And positive 24 does go in that next column over. And then I add down the column. No, try again. 5. Right? Positive 24, take away 19, will be 5. So close. Okay. So close. Okay. We've lost too much blood. Okay. We need more Band-Aids. Yes. Don't go to the light. -4 times 5. -20. And when you add down the column, you do get 0. Okay, now. This right here is the remainder. Now let me kind of walk down what we did back in elementary school. When we took 6 and divided it by 2, how many times does 2 go into 6? 3 times. How much is left over? 0 is left over, right? 2 goes into 6 3 times with nothing left over. So we say that 2 is a factor of 6 because it went in evenly, right? We use that word evenly. If it goes in evenly, then there's nothing left over. Therefore, we can call it a factor.
logic? So we just divided that by -4, and we found a remainder of 0. That means that something went in evenly. Did we know that was going to happen? No. Well, was there something that was told to you in the beginning, maybe in the red print, that was kind of indicating that was going to happen? It said that -4 was a 0. That's an x-intercept on the graph. That's helping us understand that we would get a remainder of 0. Now, what if we don't get a remainder of 0? What if we don't get a remainder of 0? Then one of two things has happened. Your teacher has lied to you that -4 is a 0 when it really wasn't. Now, more than likely, he just made a mistake. It's supposed to be like +4. He screwed up. Okay, he wasn't trying to lie to you. But that could be a problem. Or second, you messed up in your synthetic division and you need to go back and check. If something is a 0, you better doggone get a remainder of 0. Now, we're going to have problems tomorrow that we'll have remainders of 0, and we'll have some in the video tomorrow that also don't have a remainder of 0. Depends on how far we get in the video. Okay? We'll see. Now, I need you to be able to understand what you have just seen. What is the factor that we get from this? What is the factor that we get from -4? Now, the reason that the pause that you're doing right now kind of bothers me is because you and I did question 6 together. And we started out with x plus 4, and I asked you what the 0 was, and you guys spit out real fast -4. So all I'm asking you to do is go backwards. If I give you -4, what's the factor?
5.
Isn't the factor x plus 4? Okay, that's what bugs me, is when we were using the same logic, just going backwards. Okay? I know, and I need you to make that connection, that the 0 and the factor go together. Now, we divided it. What did we get? So, I need you to understand, if that's the remainder down here, then the one right next to it is the constant. And the one next to that is the linear. And what do you think the one next to that is? It starts with a Q. It's the quadratic. Whoa, not a G. If you'll notice what I just did, I went from right to left. Here's the reason I went from right to left. You guys don't make as many mistakes when you go from right to left. You make mistakes if you go from left to right, because you put the wrong degree on things. But when you go from the right side to the left side, moving this way, you guys all know that the last one's the remainder. Then you know you have the constant, +5. Then you know you have the linear term, -6. Then you know you have the quadratic term, 1x squared. You need to understand that this part right here is this. That is a connection I need you to be able to make. Say it again. Okay, so I'll put it in orange. The orange part right here is the same thing as that right there. I need people to make that connection between the two things. Now, keep factoring it. This is the part that you don't need help with. What should this factor into? X minus 5 and x minus 1. Answer the question. Remember, the question was, list all the real solutions. And I started with -4. You told me to copy it down. Actually, I told you, but you knew it. What are the other two answers? Oh, 5
bet I don't. I bet I can't. Yeah, no, it doesn't like that. Gee whiz, yeah, it doesn't like that. I know. Well, I'll argue with him about that. This process of synthetic division isn't really bad once you get the hang of it. Let's practice with number 14. Okay? Alright, so pick some other place on here. There's a lot of questions up there that we didn't do, so. So, we'll do question 12 together. We won't do 10 or 11. 9 is a bad problem, because for reasons I'm not even going to talk about, but, we won't do 9 or 10, because those are review questions. And we won't do 11, unless we need some practice. Okay? No take-backs! Okay. Alright, now this question is a little different. Here's your hint. Okay, this is going to sound weird. 0 is a 0. I know. You were thinking hero, but no. Okay, now, we need to be careful. I'm going to set this up with you. So 0 goes in the little box. My coefficients are 1, -5, or -6, 1, -6, 5, and what's the last one? What's the one on the other side of that vertical line? Ah, it's missing. It's a 0. Okay, so if I do this process with you, we carry the 1 down below the line. Multiply. What is 0 times 1? 0. Add down the column. -6. Do it again. Multiply. Add down the column. Multiply. Add down the column. Remainder 0. Ding, ding, ding. We win. What did we find? 5 plus -6x. And what's the first one? 1x squared. We need to be able to factor this. What does it factor into? Oh my goodness, it looks like the last question. Yeah, we got an x minus 5 and x minus 1, don't we? Answer the question, what are the 3 solutions? 0, yeah, you better get that one. 5 and 1. So really, it's not as bad as you think once you practice it. And we will do more when we're flexing together on Flex Day.